So in this quarter of physical science, we are going to be covering an introduction to physics. So let's start with a review from last quarter on distance and displacement. So distance is defined as the length of path between two or more points. And displacement is defined as the straight line distance. All right, so distance is the total that you travel, for example. So if I was to leave school and head home, all right, I'm going to make a couple of turns along the way. I'm going to turn right, and then I'm going to make another right, and then I'm going to make a right into my neighborhood. So I'm going to make a couple of turns. Displacement would be if I could leave school and head straight to my home without having to make any turns. That would be the displacement, the straight line distance. So in this unit, we're going to start and we're going to look at speed. Speed is the rate of motion, and it is the distance traveled per unit time. So this is why we're reviewing distance and displacement, because speed is the distance traveled per the time it takes to travel that distance. The instantaneous speed is the speed at any given instant. So I can find my overall speed going home. How long does it take me to get there? And how far did I travel? But at any given moment, my instantaneous speed may be different. I may be slowing down for a stoplight. I may be speeding up. The speed limit changes about halfway to my house. So I may be speeding up or slowing down. So speed is distance divided by time, and we can look at our average speed by doing our total distance divided by our total time. So if we wanted to set up our speed, we could do so using our triangle. Excuse me. So if I wanted to set up my triangle, and speed is going to be what we use for velocity, okay? So we are going to have V, velocity or speed, distance will be a D, and time will be a T. And you can find this on your reference table as well. This is the very first equation on your reference table, and you'll notice it's also defined for you. V is velocity, D is distance or position, and T is time. And this triangle simply means a change in, so the change overall. Since distance is divided by time, we put a D on top and a T on bottom. What's left over is my speed or my velocity, so I fill that in. So here's my triangle for when we go to solve some problems. Let's look at some basic velocity. A river flows at a rate of 3 meters per second. If the person paddles with a current rate of 2 meters per second, what is his velocity? So the river, if you're just sitting in the boat, the river is moving the boat at 3 meters per second. And if you are also paddling 2 meters per second, your overall velocity is going to be 5 meters per second. Now, what is the difference between speed and velocity? Speed is just that distance per time. Velocity is speed with a direction, and that's the key. So what is our velocity? We also have to include the direction. All right, and it tells us the direction is south. So the velocity is 5 meters per second south. what would his velocity be if he paddled against the same current? So now he's going home. He's going home at the same rate that he went, all right? And the river is still flowing south, but he's going the opposite direction. So when we have opposite vectors, if you'll remember from last quarter, Unit 1, opposite vectors subtract. So in this case, his velocity going home is 1 meter per second. And he was traveling south going, and now he's going home. All right, so he's going to be traveling north. So speed can be given in any direction. And it can change even if the speed is constant. All right, so velocity is speed in a given direction, and it can change even if the speed is constant. What? How can that happen? Remember, velocity includes two things. It includes speed, and it includes the direction. So we can keep a speed constant, but change direction, and that will ultimately overall change your velocity. So let's do some practice problems using our formula and our triangle that we've created. So I'm going to redraw my triangle so that we can see it again better. Velocity is distance divided by time. So I'm going to do distance divided by time. Velocity is left over, so there we go. We fill that in. So my neighbor skates at a speed of 4 meters per second. You can skate 100 meters in 20 seconds. Who skates faster? So basically, we need to find your velocity. So to find your velocity, I'm going to cover up V. And what am I going to do? Distance divided by time. So your distance is 100 meters. Your time is 20 seconds. And notice I'm putting in my units. So 100 divided by 20 is 5. And your units are meters divided by seconds. So you can skate 5 meters per second. Your neighbor can skate 4 meters per second, so you skate faster. Sound travels at 330 meters per second. If a lightning bolt strikes the ground 1 kilometer away from you, how long will it take for you to hear the lightning strike? So how long, that's going to be time. We are looking for time. So I'm going to cover up time in my triangle, and how am I going to solve for time? Distance divided by velocity. So my distance is 300, I'm sorry, not my distance. My distance is 1 kilometer. Uh-oh, what do I notice? My sound is in meters per second. So I have to do some conversions. So let's do a quick conversion before we plug it in. 1 kilometer has to go to meters. If kilometer is on top, remember we put it on bottom. We always have to go to a base unit, and meters is the base unit. The 1 always goes with the larger value. 1 kilometer is larger than meters, so 1 kilometer equals 1,000 meters. So my distance is 1,000 meters. And my sound travels at my velocity of 330 meters per second. So 1,000 divided by 330 is 3.03. Meters and meters cancel. I am left with seconds as my unit. So let's take this concept of velocity and let's apply it to a graph. All right? If we were to look at velocity in terms of a graph, the slope of the graph is going to be the speed of the object. If the graph is a straight line, it means it is a constant speed. The steeper the slope, the faster the speed. And if it is a flat line, that means there is no motion at all. So let's take these ideas of different parts within the graph and let's look at a graph and see if we can't apply them to that graph. So here we have our graph. The slope is the speed. So the slope of the line, and remember to find slope. Slope is y2 minus y1 over x2 minus x1. If you wanted to find the slope, that would also give you the speed. Okay, because we are doing y, and y is the distance in meters, and x is the distance or the time. In this case, it's in minutes. So I have distance divided by time, which does match my formula for velocity. A straight line means a constant speed. So in this graph, object A has a straight line, so object A is moving at a constant speed. You can see object B is moving at a constant speed for a while, and then object B's distance remains, it starts at 400 and it remains at 400. So here, object B is not moving at all. We have no motion. And then object B starts out again. All right, so maybe this is a person that's on a trip. All right, so they leave their home and they're traveling at a constant speed. They stop to get gas and maybe a snack, and then they head back out on their merry way to wherever they are going. So let's look at this graph and let's do some practice problems. Who started out faster? So that is going to be, we have to look at our slope. We have to look at our slope, and if you'll remember, a steeper slope means a faster speed. So comparing A and B, A has a steeper slope, so A started out faster. Who has a constant speed? Object A slope remains constant from start to finish. It is a straight line, so A also has a constant speed. Describe B from 10 to 20 minutes. At 10 minutes, their distance was 400. At 20 minutes, their distance was still 400. So that means if the distance did not change, B had no motion. They were not moving. All right, now it asks us to find the average speed. All right, so we're going to take the total distance divided by the total time. So let's look at A. A's total distance was 2,400 meters, and their time was 30 minutes. So their total distance was 2,400 meters, and their time was 30 minutes. So when we plug this into our calculator, we get 80 meters divided by minutes. And let's look at object B. Object B has a total distance of 1,200 meters in a 30-minute time frame. So object B went 1,200 meters in 30 minutes. So when we plug that into our calculator, we get 40 meters per minute. So there's a lot of things that we can find about an object just based upon looking at its graph.